Okay, continue about the chapter 1 about quantum computing introduction. So let's continue to introduction, and today's lecture me about some the basic elements like accelerator and some registers like in classical computers, and now we replace them with the quantum mechanics. And so the first thing is about the quantum accelerator. Current efforts are put into building a quantum accelerator, a computational add-on the classical computers to exceed current performance. And the building blocks is very important because nowadays we are learning about the digital circuit design. So we are learning about building blocks like the additional adder, subtractor, based on the NAND gate, NOR gate, and so on. They are the basic binary operation. But how to build the blocks with the quantum mechanics, quantum computing mechanics. So we need a lot of quantum algorithms, quantum language, compiler, arithmetics, and instructions and micro architecture and so on. So there are lots of things we should do. Quantum accelerator. So these are the basic building blocks in just like classical quantum. We can compare them and do something. But when we build blocks, I think it's a good way, better way to compare them, and we can get some insight from the classical one. So the main memory in the next law is about host CPU, and then the FPGA and different chips like FPGA, graphic processor unit, tensor processing unit, and accelerators, hybrid programmers, compile binary heterogeneous. Quantum materials provide the environment, and this is about the physical engineering. And physical electronic, we have the elemental unit of quantum information processing are defined and linked. Precision in material uniformity, chemical composition, and electronic properties are crucial for the requirements of chemical and transformation. Temperature are very strict for the ecosystem, so there are different like companies concerning software, hardware, and enabling technology and so on. So the industry, there are a lot about the first I think that with the development of technology, they are more and more competent because the market is booming, I think, and I hope this will have a great future. And today there are some 20 qubits, 8 qubits, and so on. Intel qubits, geotechnics skills by skills, I don't learn them well. I don't know, but I think a little bit. There are a lot of information that I can't interpret now. I hope you can share some useful information with me. And investment distribution. This is about the market and the countries in combination, and China is the first place in investment or in quantum computing research, and also patent filing for computer by country. China also in the first place. 有领先, I think. Also, what can you do with it? The factoring big numbers, and these are some specific problems that quantum computer can do now. And also, this is related fields like infinite power, and quantum simulation mechanics, science, physics, and so on. In this chapter are private maps that we need know the attraction. This is a huge task force. Maxwell's diamond Turing machine, quantum algorithm, quantum computers, data compression, cryptography, quantum key distribution, quantum information theory, and so on. We can just from these hours to the quantum world. And I think it's very easy to deliver papers in this year. I hope so. Less than 100 qubit, few small quantum networks, and if we have more than qubits, what is the new algorithm we can do more things? The internet things means what? It's not about computers, but it can do some things with quantum mechanics that delivers manipulate the properties of photons. Oh, I want to see this word. Photons, particles, light, or to build quantum networks. Quantum clock synchronization. Our internet-based society with internet bags digital machines, but we have some difficulties like encryption in the classical internet. So it can crypto also in the blockchain field if we can use the quantum computer, all of them will be done. And in order to guarantee the security, global quantum must be developed. Global quantum network, a new international, just the quantum international. Okay. In China, there's a quantum computation that is ground truth state satellite. And then the skill information and major components are about the components, anode, fibers, and repeaters. And these are the networks. Oh, I don't really well about the classical network. Maybe later I will learn about them and to post the video on YouTube. And entanglement. Okay. The major component, I think I should make more explanation. I think I just show nothing. There were few little information to others. Well, I know that basically some host and the fibers are just clockwise switches and rotors and quantum repeaters that from distance. Entanglement means that the phenomena, entanglement state that two qubits in the sense of the power of quantum internet inherently private maximum code. So I don't learn well to speed up all the around 70 years ago. Key distribution is that can be copied because of the collapse. Oh, the collapse, I think. when we measure about them to perform a long distance, I think it's I don't know them well. Distributed systems, distributed system computing is the coordinate between different computers, different processor, distributed system. The blockchain is also a huge distributed system. Deploy some sensor leader elections and community devices. Quantum communication. There exists quantum protocol that can solve such tasks with constant number of people. Very fast how many computers doesn't depend on how many computers are Oh, I don't know well about the efficiency of the network now. Oh, but I think it's a fixed number, so we have a much higher limitation. I mean that it's very difficult to meet the high limitation of these mechanics. Entanglement is exploited to achieve maximum coordination and solve agreements problems more efficiently. Applications, spear identification, clock synchronization, and this is the main line clocks and sensing, position verification, scale identification, and telescopes means that photons, oh yeah, combined combine interaction, combined light and intelligent complain braid and so on, some applications, communications, computations. Okay, there are another field like meteorology, sensing and imaginary time intensity, human knowledge of the world, and other colonial point is mediated by what we can measure, what we can measure, what we can know. And our mind comes from our mind, our knowledge comes from what we are assessing. Heisenberg's uncertainty principle limits precisely measurement can be made. The development will lead to more powerful measurement. Also, the timing, quantum time, and next generation clocks, and I think there are some satellite GPS and so on, quantum imaging, and first generation Mac automators such as superconducting quantum interference devices and some new sensors. I think it's a little bit tricky. Gravimetions, quantum radar, and later in extreme dissection because we can what we can imagine detecting more precisely. Also, the ghost imaging, I think, uses the quantum properties of light. This is using very weak illumination, being different from the target. You can throw smoke and smooth it can reinforce the accuracy and lessen the amount of radiation exposed patient during exercise. Okay, there are some accepted before transition, so expected from before there are some expected some like communication core, commutation and simulation, motion of electrons in materials, sensors, and new algorithms and computations and so on. Thanks very much. And next, I think we'll be dive into the linear algebra.